So welcome students. In this video, let us look at some shapes of standard loci on the complex plane. So what we're going to discuss now are some very standard loci which you need to remember. The first one is mod of z minus z1 is equal to r. Here z1 and r are given to you. So if z satisfies the condition, mod of z minus z1 is equal to r, what is the locus of z? So to understand this, let us try to read this in general language. What is meant by mod of z minus z1? So if z1 is a complex number in the organ plane, z minus z1 mod is nothing but the distance between the complex number z and z1 has to be equal to r, which is a constant number. That means that z is at a distance of r from the complex number z1. That is, z is moving at a constant distance of r from z1. So what is the shape of the locus? Obviously it is a circle with z1 as center and radius equal to r. So mod of z minus z1 is equal to r represents a circle with z1 as center and radius equal to r. Circle with z1 as center and radius is equal to r. Next, what is the locus represented by argument of z minus z1 is equal to theta? Here also z1 is given and theta is given. So what is the meaning of this statement? Argument of z minus z1 is nothing but the angle made by the ray joining z1 to z is equal to theta. The angle made by the ray joining z1 to z with the positive direction of ray axis has to be equal to theta. That is, if you have a complex number z1, z should be such that the ray joining z1 to z, the ray joining z1 to z should make an angle of theta with the positive direction of real axis. So effectively the locus is nothing but ray originating from z1, the ray originating from z1 making an angle of theta with the positive direction of real axis. For example, you can be asked questions like this. So what is mod of z minus of 3 plus 4i is equal to 5? What is the locus of this? This is nothing but a circle with 3 plus 4i complex number, that is the point 3, 4 as center and having radius is equal to 5. So if you draw this locus on the organ plane, it will look something like this. 3, 4 is the center and the radius is equal to 5, hence the circle passes through the origin. So this will be the required locus. 3, 4 is center, radius is equal to 5 units. Next, if you are given a locus which looks like this, argument of z minus 3 is equal to pi by 6. So how does the locus look like? That means the ray starting from 3 and making an angle of pi by 6 with the positive direction of real axis. That is, if you take the organ plane, the 3 is a point on it and the ray has to start from 3 and make an angle of pi by 6, that is 30 degrees with the x-axis. So this will be the locus obtained by this equation. So the next standard loci is mod of z minus z1 is equal to mod of z minus z2, where z1 and z2 are two given complex numbers. For example, mod of z minus 3i is equal to mod of z plus 4. So what does this locus represent? So what is the meaning of this equation? The distance between z and z1 should be exactly same as the distance between z and z2. So if z1 is a complex number and z2 is a complex number on the organ plane, what this equation says is the distance between z and z1 is exactly same as the distance between z and z2. That is, z is equidistant from z1 and z2. So what is the locus of the point which is equidistant from two given points? It is nothing but the perpendicular bisector. So the locus of z is the perpendicular bisector of z1, z2. So perpendicular bisector of z1, z2 line segment. For example, if you have z minus 3i is equal to mod of z plus 4, that means distance between z and the point 0, 3 is somewhere here. And z plus 4 mod is nothing but mod of z minus of minus 4. That is, you have a number minus 4 here. So this equation represents the perpendicular bisector of the line segment joining minus 4 and 3. So this is the locus of z that we are talking about in this equation. So I hope this is clear. Mod of z minus z1 is equal to mod of z minus z2 represents the perpendicular bisector of the complex numbers z1 and z2. Next, this can also be written in a different way. So this is exactly same as mod of z minus z1 by z minus z2 is equal to 1. So this equation is exactly same as this equation. So even if this equation is given, the answer is same. The perpendicular bisector of z1, the line segment joining z1, z2. So here, if mod of z minus z1 is equal to some k times mod of z minus z2, where k is not equal to 1. So if k is equal to 1, then you get this locus. So if k is some number which is other than 1, this represents a circle. This represents a circle. You can derive this very easily by just squaring this. So if you square this, what is mod of z minus z1? If you take z as x comma y, z1 as given x1 y1, z2 as given x2 y2. So this becomes x minus x1 whole square plus y minus y1 whole square is equal to k square times x minus x2 whole square plus y minus y2 whole square. So if k is exactly equal to 1, all the quadratic terms will get cancelled and you get a straight line. If k is not equal to 1, the quadratic terms will remain, but the coefficient of x square and the coefficient of y square will remain same. Hence, this becomes a circle. So I hope these two cases are clear to you. If mod of z minus z1 by z minus z2 is any number other than 1. So if it is equal to 1, then it is a perpendicular bisector. Any number other than 1, it represents a circle. So the next type of loci are loci connected with conic sections, ellipse and hyperbola. So the equation mod of z minus z1 plus mod of z minus z2 is equal to k. What is the meaning of this? The distance between z and z1 plus the distance between z and z2 is constant. So this looks like the condition for ellipse, right? So if you have an ellipse whose foci are z1 and z2, so if one is s dashed and the other is s, so my z is a point such that the distance between z and z1, this distance plus this distance is always a constant. So P is moving such that the sum of distances from two given points is constant. That is the basic definition of an ellipse. So this usually represents an ellipse if, so this is an ellipse if this k is greater than, because the sum of two sides has to be always greater than the third side for a triangle to be formed. So if k is greater than mod of z1 minus z2, that is the distance between z1 and z2, then this equation will represent an ellipse. A line segment, if k is exactly equal to mod of z1 minus z2. So if k is exactly same as this distance, you cannot form a triangle, so the point moves along the line segment. For example, if the distance between s and s dash is equal to 10 units, I say that z minus z1 plus z minus z2 is equal to 20 units, which is greater than z1 minus z2 mod. Now, this distance plus this distance has to be equal to 20, so you get an ellipse. The sum of these two distances is 20, you get an ellipse. If mod of z minus z1 plus mod of z minus z2 is exactly equal to 10, so you cannot get an ellipse because this is 10. Sp plus s dash p, if it has to be equal to 10, you cannot form a triangle here. Then p has to move somewhere on this line segment z1, z2. So sp plus s dash p will be exactly equal to mod of z1 minus z2. So line segment if k is equal to mod of z1 minus z2. And no locus if k is some number which is less than mod of z1 minus z2. So if I say that this plus this is equal to 5 units, but the distance between z1 and z2 is equal to 10 units. So can you find a point such that the sum of distance is equal to 5? No, because the minimum distance has to be equal to 10. So there are three cases in this locus depending on the value of k. Here z1 and z2 will be given to you. So first calculate the distance between z1 and z2, compare it with k. Depending on which case is getting satisfied, you get different answers. Similarly, you have the locus mod of z minus z1 minus mod of z minus z2 mod is equal to constant. This looks like the distance, the difference between sp and s dash p has to be equal to k. This is the condition for a hyperbola, right? So if z1 is a focus, z2 is another focus. So if this is s and this is s dash, if this point is p, the difference between sp and s dash p has to be equal to k. This is the basic definition of a hyperbola. So this becomes a hyperbola, but if it has to become a hyperbola, you have to be able to form a triangle. So in a triangle, the difference between two sides is always less than the third side. So a hyperbola, if the number given here is less than mod of z1 minus z2. If k is less than mod of z1 minus z2. And this represents if k is equal to mod of z1 minus z2, it represents the line z1 z2 except the line segment z1 z2. Line z1 z2 excluding the line segment z1 z2. So if assume that this is equal to 10, if mod of z minus z1 minus mod of z minus z2 has to be equal to 10, so the locus will be the line z1 z2 except this segment, because within this segment difference between these two cannot be equal to 10. But if the point lies somewhere here, this distance and this distance, the difference will be always equal to 10. The difference will be always equal to 10. The outer mod ensures that you get this arm as well as this arm. Next, if k is greater than mod of z1 minus z2, so you have no locus, because the difference between two sides of a triangle can never be greater than the third side. So you won't form a triangle, you won't form a straight line, so you get no locus if k is greater than mod of z1 minus z2. So these are the cases regarding the conics, ellipse and hyperbola.